let's expand on that a little bit more. Okay, so in an ideal dilute solution, the solute obeys Henry's law, which I'll write down soon. And maybe you remember Henry's law from Chem 109. That's gas solubility. And the solvent obeys, as you might guess, Raoult's law. Okay, so now, for example, here's a fictitious example here. So let's say mole fraction of B. And so we remember that we always have mixtures. So there's A and B in this mixture. And so I could make a new top scale right here, chi A. When chi B is 1, chi A is 0. And when chi B is 0, chi A is 1. And so now what's going on here, we haven't identified which one is the solvent and which one is the solute. But it's generic. We could have either of these as the solute or solvent for this example. Okay, so I'll show you here. So if we look at sparingly small additions of B. So in other words, we're making a solvent with A, and then now a solute with B. So here I'll say B is solute. And I can say B is the solute because most of the time, I mean all of the time really, our solute is going to be the least concentrated thing in the mixture. So it's going to have the smallest mole fraction. And look at this. It's hovering, you know, along Henry's law, this green line. Okay? So Henry's law is just very simple. It's just PB equals chi B times the Henry's law coefficient, KB. So it's just a simple equation, okay? But now if we follow this, so this is B as the solute. So now if I look at PA, for example, it will be chi A. Or really I have to say the solution. So the vapor pressure of A in the solution is going to be chi A times the pure vapor pressure of A. Okay? And if we look at that now here, as you can see, so let's see, like it's not showing us A, it's just showing us B. So you can see now on the opposite case here, we'll say B is now the solvent because at a mole fraction of 1, it's the predominant species in the solution. And A has a mole fraction of 0. And of course, as we move down this line, we're adding A in small additions. So now A is the solute. And you can see in this case, here where B is the solvent now, it's following the Raoult's law line, right up to a certain amount of addition. So like maybe that much, it follows the Raoult's law line when it's the solvent. And now it follows maybe that much of Henry's law when it's the solute. So this is what makes an ideal dilute solution. It's ideal under dilute conditions. So here's a real example of chloroform and acetone. And chloroform and acetone, they're kind of going to interact. They're going to kind of have similar properties. They're both certainly polar. Yes, they're both certainly polar, right? Yep, acetone looks like this. Chloroform is C hydrogen and then the 3 chlorines, okay? But they're still fairly dissimilar. And that's evidenced by the fact that they don't make an ideal solution at all additions. So for example, if I look at acetone here, and then keep in mind, right, mole fraction of chloroform is 0. So that means at this point, the mole fraction of acetone is 1. So we could say on this side, acetone is the solvent. And it's following Raoult's law for, you know, some sparingly small addition. But now when I go, if I keep following down the acetone line here, right, keep following it down, now, aha, look, when now chloroform has become the solvent and acetone is the solute, it's following Henry's law. Okay, So keep track of that. So solute obeys Henry's law, solvent obeys Raoult's law. And in the case of two liquids, so with two liquids, or really two volatile substances, they can switch, right? One can be the solvent, one can be the solute, and that can switch based on how much of it is being added. Now, if we have a liquid and a solid, and we're making a mixture out of a liquid and a solid, that's not going to be the case. The solid is not volatile, okay? And it doesn't do anything. So let me actually back up and say, on Raoult's law here, if solute is a solid, and it makes an ideal solution, then the vapor pressure of the solution is only given by the solvent. So maybe chi A times PA star, and that's it. Because if, let's say, so if the solute is a solid, and we'll call that B, it doesn't have a vapor pressure, okay? So we don't have to worry about it. So this example of ideal dilute solution is really the case with two liquids making a mixture, so two volatile components.